available, so that would be well and good. Otherwise, I have
Okay.
to basically arrange some resources. But right now, what we can do is we have like around the 30-minute session left. So, okay, so let's discuss the basic thing, which I have got the idea that from your book that the first chapter is motion chapter. So, okay, so let's discuss the same. Okay, Ibrahim?
Yeah.
Great.
Ask it
So,
loud.
are you saying something?
My father's asked if you can speak a little louder because the volume here is really like not audible.
Uh, like I'm
Is that okay?
basically, yeah, I'm speaking like basically the mic volume is boosted. So please check if your mic or like speaker volume is also boosted or not. Hello.
Yeah.
Yeah, am I audible? Because
Yeah.
I'm speaking, but it seems like my mic volume is also boosted from my end. Hello.
Yeah.
Now,
It's okay. You can continue. Yeah.
okay. Okay, just give me a second. Just a second.
Oh.
Give me a moment, Ibrahim. Just give me. Okay.
Okay.
Okay. Okay. So let's start the class. So the first thing that you have in the syllabus is basically the displacement and distance topic. Okay. So basically, let's talk about what distance and displacement is in simple manner, right? So the first thing is basically distance. So if you talk about distance, suppose that Ibrahim, you are living in Saudi. Suppose you are standing a point A, which is a landmark, right? And you are going to the specific point. So Ibrahim, if you are going, so obviously there would be no straight path. There would be some sort of like streets, some sort of highways, some sort of, you can say, avenues, which will be crossing, yes or no?
Yeah.
Right. So obviously you will be, it's not a, like, it's kind of zigzag, like different patterns basically would be there because roads are not straight,
Yeah.
right? So basically, so in that case, uh, Ibrahim, the distance would be that actual path that you are covering from point A to point B. Doesn't matter like how basically what path it is. Basically, it is all the path that you have covered, all like from going to this distance like this. So this is what the distance is. Okay, Ibrahim.
Yeah.
Clear. So distance is the actual path that you are covering when you are going from point A to point B. That means your final point, initial point to the destination point. Okay.
Yeah.
That's what the distance is. Okay. So if we talk about the displacement, so in simple word, displacement is the shortest path between initial point and the final point. Right. So it is the
Yeah.
shortest path between initial and final. So it is always a straight line. When we are talking about displacement, it is always going to be a straight line from the initial to final. So as you can see this thing, Ibrahim, the boy has started in this figure has started from this point, and it is basically this is the ending point. So the straight distance between the straight line between the A and B, yes or no, Ibrahim?
Yeah. It's shorter.
Right? So it's shorter and it's also a straight line. So whatever the
Yeah.
shortest path it is, it's basically called as a displacement. Clear?
Yeah.
Any doubt so far here?
No.
Chalo, that's good. So if we talk about the basically nature and the properties of the distance and scalar quantity, basically quantity. So distance is a scalar quantity. Have you heard about scalar and vector, Ibrahim?
No.
No. So basically, scalar quantities are those quantities which only have magnitude. Magnitude means size. If we talk about distance, so distance is a scalar, so that means it only depends on the magnitude, the value of the number. So if I'm saying Ibrahim, 3 kg, so 3 is the magnitude which is representing the size of the quantity, and kg is representing the unit. Okay.
Yeah.
Okay. So that means if the quantity is only depending on the magnitude, it is called scalar quantity. Okay. So distance is a scalar quantity. That means when the body is going from one point to another point through the actual path, this is called distance. And the displacement is a vector quantity. That means it has both magnitude plus direction. Direction means it depends on direction. So if you are going from one point here, this is east direction. If you're going to south, it is basically the value of the displacement will change. It is depending on direction as well. That's what vector quantities are. Okay.
Okay.
Yeah. So this is the basic outline of the distance and displacement. Please note it down, Ibrahim, this thing, so that you can have the idea. Yeah. Please note it down in your notebook or whatever you have to take down the notes.
Okay. You know, finished.
Can you say something?
Finished.
Okay. Okay. So as you can see in the another figure, Ibrahim, that this home. Okay. So suppose that this is home. Okay. And this is your school, right? So if you are going from one point to another point, so the actual path that you will take to go from home to school, that is called distance. But the shortest part, whatever the shortcut between the home and the school is the straight line path, that will be called as displacement. Okay.
Okay.
Great. So okay. So here, Ibrahim, there are some basically basic things regarding the distance and displacement. First thing is basically distance is always greater than zero, Ibrahim. So it means that if your body is moving, if you are moving, so distance is always going to be a positive thing. It's not zero, it's not negative. If it is in rest, it would be zero. But if the body has started in motion, that means the value of the distance would be positive.
Okay.
Right?
Yeah.
All right. Next thing is basically, Ibrahim, if we talk about the distance measured in the vehicles, it is done by the odometer. Okay. And the SI unit, the international unit that is followed by the world, like basically worldwide, is the meter. So basically, we measure the distance in the meters. Okay.
Okay.
Yeah. Please note down these points. After that, we'll discuss about the displacement, what displacement is. Done?
Awesome.
Now let's talk about the displacement. Displacement is a little bit different, but basically it's you can say that the shortcut of the this final point and initial point. But if we talk about in terms of physical quantities, it has both magnitude and basically direction. But and basically next thing is basically if we talk about distance and displacement comparison, Ibrahim. So the thing is distance is always going to be greater than the displacement. In only single case, the distance and displacement would become equal. The case is when the body is moving along a straight line. So the body, when the body is moving along a straight line only, then the displacement and distance would be equal because there is no other part to follow, right?
Yeah.
And the next thing would be, Ibrahim, that displacement can be negative, positive, and zero because it is a vector quantity. So it has direction. So if you take one direction as positive, automatically the another direction would become negative. Okay. And the unit of the displacement is also meters. Clear?
Okay.
Yeah. Please note it down.
Finished.
Okay. Just so if you talk about the positive and negative, what specific positive displacement and negative displacement is, right? The first thing is basically, Ibrahim, that positive means that if you have, suppose that if you are going from A to B and the value that you have taken is suppose that you have covered 20 meter, right? And the value is positive, right? If you have taken that, the right direction as positive. So automatically the
Okay.
opposite direction of that, this motion would become negative. So in the physics, we have two directions, like either if I'm in the straight line motion, either going in the right side or the left side. So it would become either positive or negative. So by default, the right side is taken as positive. So automatically it would become negative, which is the opposite side. Okay, Ibrahim?
Yeah.
Great. So in that case, Ibrahim, if you go from A to B and you are coming from back B to C. So C is the final point that you have taken. So ultimately, Ibrahim, this this C point is on the same line. I've just drawn it so that you can actually understand what is the basically the difference between A and C point, right? So when you go from
Yeah.
A to B, what should be the distance that you have covered?
10, 10 meters.
20. A to B. I'm saying A to B. It's 20 now.
I to B is 20.
Yeah. And if you're going from B to C, what is the total distance when you're going from A to B and B to C?
Like total 30 meters.
30. Because I said the distance will always get added if you go in the, like, it doesn't matter in which direction you are going, the distance will always go in basically add up. But the displacement is different from the distance. The reason is because we consider the direction as well. And if you go from A to B, then B to C. So you have taken this direction as positive 20, but this direction is negative. So when you add them up, the direction sign becomes negative. So only negative is showing that opposite direction. It is not saying that minus 10 meter. It's not key less, it's zero, less than zero. No, it is only showing the direction of that motion. Okay, Ibrahim?
Yeah.
So that's why the displacement would become 10. That means the actual path, that actual displacement, the shortest path between initial and final point is 10 meter. This is 10 meter. Clear?
Yeah.
From A to. Got it, Ibrahim? Any doubt so far here?
No.
Similarly, if you talk about the negative displacement, so that means if you're going from A to B is 10 meter, but from B to C, you're going in the opposite direction, but the distance covered is 20 meter. So in that case, Ibrahim, the value of distance would be 30 because distance does not depend on the the direction. It only depends on the magnitude. So it will always gets added, right? That is 20 meter plus 10 meter. That is equals to 30 meter. Clear?
Yeah.
Next is, but if you talk about the displacement, Ibrahim, that 10 meter is in the opposite, the A to B right direction, but 20 meter in the opposite direction. But when you add them up, this would become minus 10 meters. So minus 10 meter is showing that you are going in this direction up to 10 meter. That is opposite direction of the motion. So that's why it is negative. Doesn't mean it is less than zero. Clear?
Yeah.
And if you talk about the zero displacement, Ibrahim, it says that zero displacement means the body has basically has covered the same amount of distance from where it has started. In simple words, the body has come at the same point from where it has started, A to B, then B to C. 20 in this direction, 20 is in this direction. So that's why the displacement would become zero, Ibrahim. As I said, displacement can be positive, negative, and zero. Clear?
So in the sense, when you're asking the distance of someone traveling, we'll have to add them. But if
Yes.
you ask for the displacement, we have to
Yeah.
minus them.
No, we don't have to minus. It doesn't like I'm saying. It does not mean that it would be you have to minus every time. It depends. If the bodies are in same direction, you just have to add them. If the bodies, one of the motion is in the opposite direction, that portion will get subtracted because it is in the opposite direction. Nah?
Ah, okay then.
Right? Got it?
Yeah.
Please note it.
Okay. Finished.
Have you written all this thing with the diagrams?
Maybe the diagram.
Yes. Obviously, Ibrahim, you have to write all the things because that is the main question to understand. Na? I'm just giving you the outline so that you can understand properly. After that, once I'll get your book, I'll try to basically structure. Then after that, I'll basically structure your sessions according to that. Right now, I just have the idea of displacement that you have in your syllabus. That's what we are doing. Okay.
Okay.
Please write down each and every point that I have written over here.
That's finished. Finished.
Finished. Okay. Please do this. Try to do this question. If not, I'll explain. Don't worry. Just I'm giving you as a basically just to try it.
Wait, could you explain the question so I could understand it and answer it?
The question is saying that suppose a particle is there which is moving in a circular path, right? So it's basically like this. Okay. So particle is there. So suppose that Ibrahim, that the body has started from point A here, right? So it is going in this direction, right? Like this. Okay, in the circular direction. So it is asking that what will be the displacement after a half circle? That means from Ibrahim, this is the half circle, right? So the body is at point B, suppose, right? So this is
Yeah.
basically point B over here. The body is, the question is asking what will be the displacement. Displacement is the shortest path. So please, and the radius of this would be r. So please now try to do it.
Finished.
Yeah, let me know the answer, Ibrahim.
Is it C?
Yes, that's right. It's very good. It's C because the 2r is the smallest distance between them. Okay. Please write. Please try to solve this question.
Okay. Finished.
Please let me know the answer.
1 second. I have a question. When I'm adding the equation, will I have to add 200 plus 40 or 2 plus 20?
The question is saying that an athlete is there which is covering 200 meter in 40 seconds, right? 200 meter of basically circular. Okay, so basically an athlete is there which is covering the circle of 200 diameter. So the question is asking what is the distance after 2 minutes and 20 seconds. That means the question is asking after 140 seconds, how much distance and displacement he will cover.
Okay.
Yeah, please do it.
Finished.
Yeah, please tell me.
The distance is 240 meters while the displacement is 22 meters.
Distance is 240. Let's check it out. That's wrong, Rami, Ibrahim. Because it is a circle, Ibrahim. It's not only a normal path, it's a circle. So the circumference will be telling the distance because you are moving along the boundary. You are moving along the boundary. So it is 2 pi r. So it's asking how many, so basically in 140 seconds, the athlete will cover 3.5 rounds. That means 3.5 times of this complete circle. That is 3.5 into 2 pi r. Okay. And 7 pi r, when you 3.5 into 2. So 7 will cancel this, the value of pi, that 22 into 100 would left, that is 2200. Please tell me the answer for the displacement, Ibrahim.
22.
It's basically the distance. What is the value of displacement?
Is it 22?
No,
Then read the question. Read the question. Read the task. Just 1 second.
are you saying something, Ibrahim?
1 second. How do we find displacement equation?
There is no equation, Ibrahim. As you can see, the body is covering 3.5 rounds. So first he will come back at point A, but in the last round, he would go to point B. So that is the fifth, basically half round. So the displacement would be the 2r. That is nothing but the diameter, 200 meter, or you can say, got it?
Yeah.
So that's why. Please note it down, Ibrahim. Is that clear or not? Please tell me.
Yeah.
Any doubt?
Answer. I have one doubt.
Yeah, please tell me.
Why for T you add 2 times 60 plus 20 to get 140? Why do you do that?
Ibrahim, it's basically the 2 minutes and for 20 seconds. So if you wanted to convert minutes into second, you have to multiply it with 60 seconds. Huh?
Oh, okay.
Yeah. So that's why 2 into 60 means 2 minutes would be equals to 120 seconds.
So you have to convert it, then add it.
Yes, obviously, because the SI unit of time is seconds. Okay, so that means because if we talk about the like the value, so we are talking about the meter seconds is already given. It's in seconds is already given. So we have to convert this thing into seconds, Ibrahim, because it's the SI unit. Clear?
Yeah.
Any doubt?
Give me a second, please. Give me a second. Hold it. Hold it. Yeah, thank you. Make me mute.
Excuse me, teacher.
Yes, Ibrahim.
In the 3.5 times 20R, what is that digit after you times 3.5x? 3.5
It's
times
pi,
20.
pi. 2 pi
So
r.
what's the answer for 3.5 times 20R? Like, what's that digit?
I didn't get it.
In distance, after
Mm,
3.5x times
it's
20.
yeah, it's not 20, it's pi. Pi is a constant. Whenever, like, do you know formula of 2 pi r, the circumference, area of circle?
I no.
What is the area of circle, Ibrahim? Hello?
Is it?
Area of circle. How much?
Pi r square. Pi is the constant which we multiply. Pi is basically the constant 3.14 or 22/7. So this is what pi is, because we are calculating the distance, that is the circumference of the circle. So that's why this is 2 pi r. Circumference of the circle is 2 pi r, the boundary. So this why that means 3.5 times of the one circumference. That would become 7 pi r. This is the total distance the body will cover in the 140 seconds. Clear?
Yeah.
Yeah. So that's what the pi is. Pi is basically the constant that is getting multiplied over here because it is in the formula. The pi, the a circumference formula, area formula. Okay.
Okay.
Yeah. Okay, that's great. So with this, we have completed this topic, Ibrahim. Please do let me know if you have any doubt apart from this.
Yes, actually.
Yeah, please tell me.
For displacement and distance, when you identify them, isn't there like a specific formula?
Didn't get it.
Isn't it like a formula for displacement and
No, there is no
distance?
formula for displacement or distance, but you just have to add them depending on your critical thinking. That like in distance, it's straightforward. Whatever the values are given, path is given, you just have to add them. But in distance, you have to make sure that in which direction the body is going and what is the opposite direction of that body is. So if it is taken as negative, so you just have to subtract it. There is no specific formula for it, Ibrahim.
Okay.
Yeah. Okay. Okay, Ibrahim. So anything else?
Uh, no, not really.
Okay, that's great. Okay, Ibrahim. So with this, let's end this class over here. In the next class, like I'll try to find your book on the internet if available, so that I can structure your content. Okay. So with this, let's
Yeah,
end
good
this
afternoon.
class. Yeah, sir.
How are you?
I'm good, sir. How are you?
You're from which part of India?
New Delhi.
New Delhi. Very good, fantastic.
Yeah.
Because your English is not like like other part in India. That's what I asked you, which part of India.
Yeah, sir. Actually.
By the way, basically what I need from you is
Yes, sir.
Ibrahim. He just promoted to the grade 9.
Yes, sir.
So just now, only 1 week we had a school for the grade 9, and
Mhm.
also from that one, I think today is the first day of the syllabus they had.
Okay.
Well, 1 week just playing